Hello, welcome to a statistics presentation on the binomial probability distribution. Here's the problem. Your company's internal auditor believes that 10% of the company's invoices contain errors. Stop right there. That's a claim. The claim is that 10% contains errors. We don't know if it's true or not. That's just his claim, the company's internal auditor. Okay? To check this theory, 20 invoices are randomly selected and 5 are found to have errors. Stop. That's your test. So they did a survey. They took 20 invoices. There probably, I don't know how many invoices there are, but there's more than 20. Maybe this is a company and there's maybe thousands of invoices. So we took a sample of 20 from a pool of many, and it was found that 5 had errors. Well, from that sample, 5 out of 20, well, if I do that calculation, that's more than 10%. 5 out of 20 is 25%. Well, that's not what we're referring to. That's just the test. And let's look at the question. It says, what is the probability that of the 20 written, 5 or more would contain errors if the theory is valid? That statement makes this a binomial probability distribution. What we're going to do, we're going to assume from the claim that 10% of the company's invoices contain error. So we're going to assume that. Okay. Now let's make sure that this is in fact binomial. Well, we look here. Number 1 says the number of observations is fixed. Well, we had specifically 20 observations. So that's set. Number 2, each observation is independent. Each observation, basically each invoice selection is independent from the next invoice selection. One does not affect the other. The probability of one event does not affect the probability of another event. Okay, so that's true. The third one, each observation represents one of two outcomes, success or failure. Success is, in this case, our success will be having an error, since we're going to go off of the assumption of 10% that contain error. And the fourth one, the probability of success P is the same for each outcome, and our probability of success is 10%, which is 0.1. Okay, so what we're going to do is look at the binomial probability distribution. We're going to look at our distribution from here. Let's identify, when you're looking at a binomial probability distribution, your first thing you want to do is look at the set number of trials. In this case, we have 20 trials, so our N is 20. Our probability of success in this case is going to be 10% or 0.1. Now we're going to pause and we're going to go to our software. You could do this by hand, but it's probably easier to plug this into some type of software to get your distribution values. And let's go to the software.